Hi, BBTECH students. In this video, we are going to talk about the final exam from the last year, 2022. So we're gonna continue where we stopped in class. So we're gonna continue the solutions or the answer key to the final exam from last year. So remember that the date for this year is gonna be the December 1st, 2023. So make sure that you show up on the exam date as well. So let's go. So we're gonna continue to the question that we haven't done in class. So question 1 we already did. So it's the multiple choice question. So we're gonna move to question 2 here. It's a show your work question. So the average zinc concentration recovered from a sample of zinc measurements in 49 different locations is found to be X bar equal to 2.614 grams per millimeter. Assume that the population standard deviation is sigma equal to 0.3. So part A. Can you find a 95% confidence interval for the true mean zinc concentration mu in the river? So basically, they ask you for a 95% confidence interval. So, and the answer asks you to round the final answer into 3 decimals. And you have the R code here. This is the one that's gonna help you to find the critical value. All right, let's go. So in the formula sheet, you're gonna have the formula for the confidence interval. So you can just go from there because a 95% confidence interval for mu. In the formula sheet, you're gonna have 2 formula, which you can pick which one you're gonna choose based on the information in the question C or T, right? This one you're gonna see that you have 49 different locations. So this one basically give you that the information is n equal to 49. So the sample size is big enough. So when the sample size is big enough, you can use the C statistic, which is going to be X bar plus or minus C alpha over 2 sigma over square root n. This time you know sigma. So you actually have the value of the sigma here. You have value of X bar here. You have value of n here. And then you plug in everything that should complete the question easily. So X bar gonna be 2.614 and then plus minus C alpha over 2 here. Use a technique that we learned in class. So we're gonna draw the normal distribution first, and then we have 95% confidence interval. So we save 95% in the middle, and then on the tail you're gonna have 5% on both tails. So that means one sided tail you're gonna have 2.5%. And this is where you stand here. So where you stand here, you're gonna have 97.5% on the left tail. I mean on 97.5% on the left where you stand here. So this one should be Q norm 0.975, which is 1.96 here. So that means you're gonna have 1.96 here. And then sigma over square root n gonna be sigma is 0.3. Square root n is root 49 here. And then you just compute everything. So it's gonna be 2.614 plus minus 1.96. So the thing that you need on the exam is the calculator. So we're gonna compute it here. So 0.3 over square root 47, which is 9. So here we're gonna have 0.0428. All right, and then you just compute this one. So I'm gonna compute each this term and this term first. So 1.96 and 0.0428. Right, so I'm going to hit the calculator. This is actually 0.084, and then once you have that one, so it's 0.614. So I'm hitting the calculator now, and then plus minus 0.084. So the answer gonna be 2.530 and 2.698. All right, this is the confidence interval, a 95% confidence interval for mu. So in part B, we're gonna ask you for the question about the components of the confidence interval. So the question basically asks you to fill in the following quantities. So you're gonna have point estimate, standard error, and margin of error. So as I told you before, that the point estimate gonna be this one. This is a point estimate of mu, so you use x bar, so it's 2.614. So the standard error of x bar gonna be this term. This is called the standard error of x bar, so that means 0.0428. So this is the standard error, one more time, of x bar is sigma over square root n. And then the margin of error gonna be this term. This is the error bound that you have, because when you build a confidence interval, 2.614 gonna be in the middle, and then you extend the hand on both sides. The length that you extend both hand, this length gonna call E, the margin of error. So in this case, it's gonna be 0.084. Okay. All right. So the last part for this question. So how large a sample is required if we want to be 95% confident that our estimate mu is off by less than 0.05. So basically, this is a question about the sample size. So you can look up at the sample size formula in the formula sheet and then go from there. So basically, this is the question that asks you, if we want to estimate mu and we want the error bound to be close to the mu, but the error you want it to be less than they want the error to be less than 0.05. So that means they want E to be 0.05. So they just want our estimate to be close to mu with E equal to 0.05. And then the alpha used gonna be 0.05 as well, because this is actually the 95% confident. That means if you want to use alpha over 2, it's gonna be 0.025. So in the formula that you have, so you can take a look at the sample size necessary, and then you're gonna have n equal to c alpha over 2 and then sigma over e and then square, and then this is going to be c 0.025, sigma gonna be 0.3, and then e gonna be 0.05, and then you square. So remember, C0.25 here is actually the same as what you did before, because this is actually where you call C 0.025. So this is Q norm 0.975, and that is 1.96. So you can keep doing it. So 1.96 times 0.3 over 0.05 and then square. So we're going to hit the calculator now. So 1.96 and then multiply 0.3 and then over 0.05. So once you get the number here, you have 11.76 and then you square. So you square 11.76, so you get 138.2976. Well, I mean, we cannot draw a sample with decimals, so we have to round it up to an integer. So that means n equal to 139 is required. Basically, whatever you get, as we learned in class, you're gonna need to round it up. All right, so done with the first question. All right, next one. We have one more part here, sorry. So the next one is, now consider the similar situation. Now the average copper concentration recovered from a sample of copper measurement in 81 different locations is found to be Y bar equal to 3.035 grams per millimeter. Assume that the population standard deviation for copper is sigma equal to 0.3 as well. So can you calculate a 90% confidence interval for the difference in mean between copper and zinc concentration? So basically, here you're gonna need a 90% confidence interval. So the difference is that this is a two sample analysis. So you just need to look at the different population parameter. So now you're gonna do mu. Well, you actually do mu copper minus mu zinc, right? Because you wanna look at the difference in mean. So you're gonna do mu copper minus mu zinc. So this is actually your parameter, and you wanna build a 95% confidence interval for it. So in the formula sheet, you're gonna see that you have the formula for the two sample as well. For this case, you see that the sample size is very big because you have n equal to actually, well, let's summarize the information first. You're gonna have the information for the copper NC is equal to 81. NC is equal to 81, and then you have okay, let's use N1 and N2. So it's easier that way because we actually have the N1 and N2 here. So N1 is the copper one, and N2 is equal to the zinc one, which is 49. So this is N1 refer to copper. Mu2 here gonna correspond to zinc. All right, so what we're gonna do is we're gonna copy the x1 bar, which is 2 point, oops, sorry. Yep. All right, let's do it one more time. So x1 bar, which is 3.305, and then x2 bar, this is actually the 2.614. All right, and sigma, both of them are equal to 0.3. All right, so it's a little bit odd on this question because we want to build a 95% confidence interval for the difference in mean between copper and zinc. So you can do both way. I mean, if you want to do copper minus zinc, you're gonna get the same answer as me. But I mean, if you want to do zinc minus copper, that is totally fine too. I mean, it depends on you. But for this question, I'm gonna do copper minus zinc, okay? If you want to do zinc minus copper, that is totally fine too. All right, so we're gonna build a confidence interval. So the formula in the formula sheet is actually x1 bar minus x2 bar, and then minus mu1 minus mu2 here, and then over square root. Well, I mean, if you actually know sigma, so it's gonna be sigma 1 square over n1 plus sigma 2 square over n2. This is a formula that you can use when n is big, right? When n1 and n2 greater than or equal to 30. So when the sample size N1 and N2 are big, so you can use the C statistic here, so which you can build a confidence interval from there. So 90% confidence interval for mu1 minus mu2. This is going to be x bar 1 minus x bar 2, and then plus minus C alpha over 2, and then square root sigma 1 square over n1 plus sigma 2 square over n2. And then you plug in everything, you should get the answer you want. So x bar 1 is 3.035, x bar 2 is 2.614, and then C alpha over 2 here, we're gonna do 90% confidence interval, so we're gonna save 90% in the middle. So the tail gonna be 5% here. That means where you stand here, this is actually Q norm 0.95 because you actually have 95% on the left of you, 95% of the distribution on the left of you, so you need Q norm 0.95. So it's actually 1.645. If you don't know this number, you can go go to the code again, and then you're gonna see you have Q norm 0.95 here, which is 1.645. All right, and then you're gonna use it here, 1.645, and then you plug in this, so you're gonna have square root, and then sigma 1 over n1, and then sigma 2 over n2. All right, and then once you compute everything, so you're gonna get the answer. So this is the final answer that you want. So what we're gonna do is we're gonna hit the calculator now. So 3.035 and then minus 2.614. So this is actually 0.421 first, and then plus. All right, we're gonna do that term, the margin of error. 1.645 times square root 0.3 square over 81, and then plus 0.3 square again, and then over 49. So this is actually 0.089. And then what you're gonna do is you're gonna just compute the confidence interval here. So let me do it. So 0.421 plus or minus 0.089, and that is going to be 0.332, comma 0.510. All right, so this is actually the confidence interval that you get, 90% confidence interval for mu1 minus mu2. So what happened is you can also answer the question, the last question here. They say that based on the confidence interval, do you believe that the true mean of copper concentration differ from the true mean of zinc concentration? Explain. So when you see this type of question, you already did so many times. So that means you have to check that the confidence interval include number 0 or not, right? Because if the confidence interval include number 0, it means 0 is the possible value for this confidence interval. And that means you still, that there is a chance that the mu1 minus mu2 gonna be 0. So there is a chance that mu1 equal to mu2. That means you do not believe. But I mean, if the confidence interval do not or does not include 0 here, that means you believe that the difference gonna be in between, difference between two means gonna be in between this number to this number. So it does not include 0. So that means you believe it. You believe that the true mean of copper differ from the true mean of zinc concentration. So we're gonna answer here is yes. We do believe that the true mean of copper concentration is different from the true mean of zinc concentration. Because the confidence interval does not include 0. All right, so this is the answer for this type of question. So this is the two sample confidence interval, okay? All right, so let's go. Next one. So we're gonna do part 3 here. So a manufacturer of gunpowder has developed a new powder, which was tested in n equal to 8 shells. So this is a sample size, very small one, so n equal to 8. All right, this is a number, and then you actually assume that the muzzle velocities are approximately normally distributed. So the distribution is normal. I mean, the distribution of the data is normal. And then the basic summaries are x bar equal to 2959, and then sample variance s square equal to 1528. So calculate a 95% confidence interval for mu. R is given here. All right, so this time for sure you're going to use a t distribution because the sample size is small. You don't know sigma and the population is normal. So that means you're going to use t. So we're going to write out one more time. So normal distribution, data is normal distribution. I mean, the data is normal distribution. Sigma unknown sigma is unknown. And then when you have small sample size, so you're going to use the t distribution. So once you decide that you're going to use a t distribution, you can build a confidence interval easily. So at 95% confidence interval for mu. So this is going to be x bar plus minus t alpha over 2 s over square root n, right, from the formula sheet. And then now you're going to have x bar, which is 2959, and then plus minus t alpha over 2 here, going to be qt. All right, keep in mind, this is 95% confidence interval. So what you have here is 2.5%. So this is actually qt 0.975. And then comma degree of freedom. Remember that the degree of freedom gonna be n minus 1. From the formula sheet, you can see it. So it's gonna be 7. So, and then this number, and then you multiply s, which is square root 1528. And then n, which is square root 8. This number is s squared. 1528 is s squared. When you use it here, s, you need to take square root, and then n is here 8. All right, so you're ready to plug in everything, but remember that the question give you the value of the qt 0.9757, which is 2.36, 2.3646. Then you square root that one. All right, so let's hit the calculator. So 2959 plus minus. All right, and then square root 1528 over 8. So this is actually 2945.18, and then comma 2972.82. All right, so that is the part A. So part B. So if you use the same data to build 93, 95, and 97% confidence intervals for mu, which one is the narrowest one? So basically, when you use the same data set to build a confidence interval, so the center gonna be the same, right? So the center gonna be the same, which is x bar, and then the margin of error gonna be different depending on the critical value that you put on. So basically, if you put 93, 95, 97%, the difference is that you're going to use different number here because 95% is here. If you use 93%, so let's think this way. If you have 95%, you stand here, the way you cut. If you use 93%, so the area on the middle gonna be smaller. So you're gonna have more area on the tail. And that means you're gonna move yourself a little bit, move to the left a little bit. So that means the number here gonna be smaller, right? The number here gonna be smaller if you use 93%. If you use 97%, you're gonna move to the right a little bit. So that means the number here gonna be a little bit bigger. So that means the confidence interval gonna be narrow if you move the confidence level down. right? The 93% confidence interval is the answer, because this one is the narrowest one. Because once you decrease your confidence level here, this number is gonna be smaller. That means it's gonna make a confidence interval smaller, because actually this number, they are fixed, so they stand there. So because we use the same data set. All right, next one. In part A, you were asked to find a 95% confidence interval for mu. In general, how would you find A1 minus alpha times 100% confidence interval? Explain. Observe that 95% is a special case when alpha equals 0.5. So if you need 1 minus alpha times 100% confidence interval, what we're gonna do is, if you want to explain how to do it, so you're gonna need to, the thing that is differ from 95% is that you're gonna save 1 minus alpha in the middle. So you're gonna save 1 minus alpha 100% in the middle of the t distribution. So that means you're gonna have this ship, and then 1 minus alpha times 100%, right? You save it in the middle. So that means on the tail, you're gonna have alpha on both sides. You're gonna have to add them up to alpha, which means you're gonna have alpha over 2 on both sides. This implies area. This implies that we have alpha over 2 area on both tail. So once we have alpha over 2 on both tail, so we can use the qt command now. And then, because this is actually alpha over 2 on the right hand side, so where you stand here, you're gonna have everything else here on the left hand side of you. So we're gonna use qt 1 minus alpha over 2 and then follow the degree of freedom to solve for it, right? So it means, but degree of freedom here is actually n minus 1. So that means you're gonna have, we can use qt 1 minus alpha over 2 degree of freedom as a critical value. And then number 3, plug in all quantities, and then you will get to the answer. Plug in all quantities, so x bar plus minus qt 1 minus alpha over 2 degree of freedom, and then s over square root n. All right, this is how you find a confidence interval for the mean mu. In this case, in general, if you want to find any confidence level, doesn't have to be 95, you're going to use this algorithm. Okay. All right, next one. All right, question 4. We're almost there, because we have question 4, question 5, and we already did question 6 and 7. All right, 2 more. So question 4, a builder claims that heat pumps are installed in 80% of all homes being constructed today in the United States. Would you agree with this claim if a random survey of new homes in the United States show that 90 out of 120, had heat pumps installed? Your task is to construct a confidence interval and conduct tests of hypotheses in parts A and B. Code is as follows. So basically, we're gonna build a confidence interval and hypothesis test. The claim is that they claim that the heat pump are installed in 80% of all homes. But you draw a sample of 120. You see that 90 out of 120 the heat pumps were installed already. So question A. All right, so let's summarize the question first. You have N equal to 120, and then you have X equal to 90. So this is what you have, and then 80% is the value that you want to claim for the confidence interval later. All right, so part A. You want to find a 90% confidence interval for the true proportion of all homes in the USA that have heat pumps installed. So basically, you can look up at the formula sheet one more time on the exam. You're going to have the formula sheet for P as well. And then you look up at the confidence interval over there. We use N equal to 100. So the big sample, 120. So this is a big sample. So you're going to use the C confidence interval, right? So you can apply for this one. And then on the exam, you're going to have the formula P hat plus or minus C alpha over 2 square root P hat times 1 minus P hat over N. Pretty simple one. So the P hat here going to be X over N. This is 90 over 120, which is 0.75. Right? So you can plug in 0.75. So this is actually a 90% confidence interval for P. Right? So it's going to be 0.75 plus minus C alpha over 2. So what you're going to do is you're going to draw again, but this time 90%. So 5% on the tail here. So it's Q norm 0.95. So it's 1.645. Here it's Q norm 0.95. All right, and this question is 1.645. And then square root P times 1 minus P, this is 0.75. And then times 0.25, you plug in everything, and then over N, which is 120. All right, so we're going to hit the calculator here. We start from the margin of error first, 1.645, and then multiply square root 0.75, 0.25, and then over 120. So it's 0.75, and then plus minus the margin of error is 0.065. And then now you're gonna do the what you're gonna do is you're gonna build a confidence interval now, 0.75 plus minus 0.065. So a 90% confidence interval for P is 0.685 to 0.815. All right. So the exam this year, the format gonna be the multiple choice. So make sure that when you do it, so if you have, you're supposed to get the same number as you see in the multiple choice. But if you get the number that is a little bit twist because you round the number too early, or you round the number too early, so you're gonna have maybe different in the third or fourth digit. So that is totally fine. You still choose that alternative choices because the rounding error is just because you sometimes round the number way too early, but that multiple choice is still the correct answer. All right, so next one, part B. This one we're gonna do a 6-step hypothesis test at alpha equal to 0.1. So test P equal to 0.8 and versus P not equal to 0.8. So this one is actually you have to use the C test as well, for the confidence interval, because for the hypothesis test, sorry, because the sample size is big, so you still use the C confidence interval. If the sample size is small, you can use the binomial test. So if you use the binomial test, we're gonna compute the p-value by looking up at the coding, the R command for the binomial test as we learned in class. But this one, the sample size is big, so you're gonna use the confidence interval. The hypothesis test for use a C test, that one. All right, so I keep getting you uh confused, right? Because I keep talking about repeating the nonsense thing. All right, so let's do that. Part B. So complete a 6-step hypothesis test. So step number 1. All right, let's do it. So we have the 6-step hypothesis test here. So step number 1, what we're gonna do, we're gonna do H0. This is the case that you're gonna test P equal to 0.8, and then versus the claim said that 80%, so we're gonna test P equal to 0.8 versus P is not equal to 0.8. All right, step 2, you're gonna do alpha equal to 0.1. All right, step 3. So this time you're gonna compute the C-test. All right, the statistic that you have is actually, you can look up at the formula sheet one more time. So the statistic that you have is P hat minus P0 over square root P0 times 1 minus P0 over N. All right, square root is all the way here. All right, so P hat is going to be 0.75 from the previous question. So P0 is 0.8. So remember, this is the value that you want to test. All right, and then over square root 0.8 and then times 0.2 and then over N is 120. And then you compute the C-test here. All right, I'm just doing it now in my calculator. Well, basically, you can take your time when you do it on the exam. Make sure that you get the correct answer. So this is negative 1.369, which you should have the code for there. Yeah, so you actually had the code for the P norm here. Because actually what you're going to use this one as a P value on the next step, right? This one. All right, next one. So we're going to have the C-test. Once we have the C-test, we can compute the P value. But this is the answer for the C-test here. All right, next one, step 4. Going to be the P value 1. So this time, because you do the alternative hypothesis to be not equal to psi, so you're gonna do 2 times the probability that let's see, let's draw the diagram here, so to make sure that everything is good. So you're gonna have the C-test is negative 1.369. So the left tail is here. So that means what you need is you need the 2 times the probability that C less than or equal to negative 1.369. So basically 2 come from not equal to sign here. So because you have not equal to sign, so you multiply 2. And then the area on the left tail here, you're gonna just use the R code. So it's gonna be P norm 1.693. And once you hit the P norm here, you should have the same number as you see in the question here, which is 0.0 P norm negative 1.369. This is 0.0854. All right, and the p-value is about 0.17, right? So let me use a calculator one more time. So 2 times 0.0854, so 0.1708. All right, so this is our p-value. And then step number 5, so now we can make a conclusion. So the p-value is indeed bigger than alpha. So this means you fail to reject the null hypothesis at alpha equal to 0.1, right? Because alpha equal to 0.1. All right. You can see that if you do not multiply 2, the answer is going to be different. So make sure that when you do not equal to psi, you multiply 2. All right. Next one, step 6. So you're going to make the conclusion. So there is not enough evidence to conclude that the proportion of heat pump installed in USA differs from 80%. So there is not enough evidence to conclude the alternative hypothesis. So that means there is not enough evidence to conclude that the proportion of heat pump installed in the USA differ from 80%. All right, so that is the question 4 from the last year exam. So you can do the confidence interval and hypothesis test in one question, but this parameter here is the parameter P. So you may see the question, this type question again this year, but it's gonna be on the multiple choice questions. So, well, the question can break up into smaller parts, something like maybe for the confidence interval, I'm gonna ask you, hey, what is the C-test? And then you pick the answer in one question. What is the p-value? You pick another question and then maybe make the conclusion in another question, blah, blah, blah. So that is what you expect to see on the final exam this year. All right, the last question for this clip is this question, which is the one that is similar to what you have in the quiz. So suppose that you are interested in testing the bias in pH meter. The data are collected on a natural substance, pH equal to 7. Sample of the measurements were as follows. So this is the number that you get from the sample of size 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. Right? One more time. 1, 2, 3, 4, 5, 6, 8, 9, 10. All right. So the sample size is 10. And then the question didn't give you X bar or S. You have to compute it by yourself. But the question give you the R code here. And they want you to do the mu equal to 7 and mu equal to not equal to 7. All right, so we're gonna do the 6-step hypothesis test here. So step 1, so we're gonna do mu equal to 7 versus H1. This is mu is not equal to 7. So this one you already did it in the quiz, but yeah, we're gonna repeat it again here as a solution. So alpha equal to 0.05 here, step 2. Step number 3, so what you're gonna do is you're gonna compute the t-test, right? Well, we pick the t here because the sample size is small, as you see here. That n gonna be 10. All right, so the sample size is small. So when the sample size is small, so it's actually good that the sample size is small. The sample size is small, and then you don't know sigma. All right. And once you don't know sigma, the sample size is small, and also we assume that a sample pool from the normal population. So you have normal population. So it match with the condition for the t-test. So you're going to use a t-test here. So I'm going to look up at the solution 1 second because I'm lazy to hit the calculator now. So we're going to look up at the solution. Do we have it here? 1 second. 1 second, everyone. I think I have the solution for this one. All right. Because t-test here is actually x bar minus mu 0 over s over square root n. This is the formula for t-test. But actually, we have the real data set, the raw data set actually. So we have to compute x bar and s. So I already looked up the number. When you compute x bar, so you can sum xi over n. So you can add everything up. So add this 10 number and then divided by number 10. So summation of xi over n. So you're gonna get 7.025, right? This is the number that you have. And then the next one is you're gonna have the S here, which I mean you usually use R in class, but I mean if you want to compute it by hand, you can do sum of xi minus x bar square over n minus 1. You're gonna get S, and this number you're gonna get 0.044. Right, this is your S. But I mean in class, what I taught you is we're gonna plug in this number into X, plug in all the number here, 10 number here, gonna be plugged in into X, and then what you're gonna have is you're gonna do mean of X. This gonna give you the X bar, and then we're gonna do SDX. This gonna give you the standard deviation of X bar. So in the exam this year, well, we are not going to ask you to compute X bar and S by using the formula here, but we ask you to read the output from the R code. So on the exam, you're gonna see the question, this type of question, but the R code corresponding to this question gonna be given. So you're gonna see the notation for the mean and SD here, and it's gonna show in the question that it's 7.025 and 0.044 here. So you can copy this number and use it in the t-test. All right, so to sum up, don't worry about how to compute SD because the R code going to be given on the exam. So you can just look up at the SDX and then pick up this number to use it here. All right. So this is 7, and then this is 0.044, and then over square root n, which is square root 10. All right. So you plug in everything here. So it's 1.7967. All right. This is your t-test. I mean, you can double check yourself because the R code is here. So you have the number that match here. So that's mean you actually on the right track. All right, next one, step 4. So we're gonna compute the p-value. All right, the p-value gonna be what? So what you're gonna do is choop, and then you have 1.7967. And then on the right tail, this is going to be your p-value, and then you have not equal to, so you're going to multiply 2 as well. So the p-value going to be the 2 times probability that t bigger than 1.7967. So it's actually 2 times 1 minus pt, right? 1.7967, and then comma the degree of freedom, which is 9. So remember that if you want the area on the left, it's going to be 1 minus p. Oh, sorry, if you want the area on the right, it's 1 minus pt. Because area on the left is just pt here. And the degree of freedom that you use is 9. All right, next one. So you have 2 times 1 minus 0.9470. So this number, it's here. All right, it's here. All right, and then we're going to have this number. So it's actually 0.106, right? Approximately, because when you subtract and then you multiply 2, you're gonna get this number. And then the last step is that the conclusion. Oh, the last 2 steps is the conclusion. So step number 5. So the p-value is 0.1, which is actually bigger than alpha. So you fail to reject again. So you fail to reject the null hypothesis at alpha equal to 0.05. So you fail to reject the null hypothesis. And then step number 6, so you're going to make the conclusion. So that means there is not sufficient evidence to suggest that the pH meter is biased. Well, you have the alternative hypothesis. All right. mu is not equal to 7. So mu is not equal to 7 mean the pH meter is biased. Right? That means not sufficient evidence to conclude H1. So that means not sufficient evidence to suggest that the pH meter is biased. All right, so this is similar to the quiz 1 that you did in class as well. All right, so this is the final exam from last year, the one that we haven't done it in class, so we just did it here. And then question 6 and 7 we already did in class here. All right, so I'm gonna post a solution for the last final exam year for you, but make sure that you study on the regression and chi-square as well, because the exam gonna be, the content for the exam this year gonna be much more. Well, the content gonna be a little bit heavier compared to last year. So because we have the chi-square test, we have the regression, we also have to test the linear relationship rho equal to 0 in there as well. All right, make sure you study on the final exam and let me know if you have questions. So make sure you study on all the packet that I show you in class. So good luck everyone, and I will see you on the exam date. Mahamagut building, the fifth floor. All right, thank you everyone for watching this video. Bye.